So in this lesson, we're going to continue talking about the coordinate plane, but we're going to be looking at some pictures on the coordinate plane, and specifically forming polygons. And you may or may not remember what polygons are, but those are different shapes like triangles and rectangles. Maybe you've heard of hexagons and septagons, but we're going to be just looking mostly at triangles and squares and rectangles. So yesterday we looked at distances between points, and that's going to play a role today as well. And you'll see how yesterday's lesson connects to today's lesson. So let's quickly just go over the answer to the do now, and then we will go ahead. So turn to the next page, please. All right, so in the do now, you graphed these points, you connected them, and formed a rectangle. Actually formed a square, because we can see that both the length and the width are the same. AB and BD are the same length, both equal to 8. So that's what we're going to be looking at today. And also, I threw in number 5 just to show you that you want to be able to find the distance between 2 points even when you can't graph them and count the squares. In this point, of course, you can't really do that. So if we follow our steps, the x values are 3, so we cross those out. We circled the other 2. Now here's the trick. Both of these points are in quadrant 1, because both the x and the y are positive in this, and the x and y are positive in this. So same quadrant means we subtract. So 113 minus 3 is 110. All right, let's take a quick look at the homework answers again. So go ahead and turn to that. So take a quick look at the homework answers again, and if you missed any of these, see if you can figure out where you might have gone wrong. All right, when you finish that, you can turn to the next page, and we will start the notes. So I want to do a quick review of a special polygon, a special shape. And this shape here, I think everybody knows, is a triangle, but it's a special kind of triangle. It is a right triangle. So I want you to write that here. Right triangle. And that has a special property in that one of the angles is 90 degrees. Means these two are perpendicular, they meet at a right angle, and that makes it a right triangle. So all of the triangles we deal with today will be right triangles. Now there's a couple of pieces of vocabulary I want you to make sure we know. The points that create the triangle, here, here, and here, we call those vertices. So we're going to write that term here. Those 3 points that create the triangle are called the vertices. And then we have the height and the base of a triangle. So for our purposes, we're going to call the horizontal component of the triangle the base, and the vertical component we're going to call the height. So if you see a triangle like this and somebody asks you find the length of the base, you are going to calculate the horizontal piece. And again, if they tell you to calculate the length of the height, you're going to calculate the vertical piece of it. And we're not going to be worried about the diagonal piece just yet. All right, so now that we have reviewed what a right triangle is, go ahead to the next page, and we'll see how this fits in with the coordinate axes. All right, so let's read what we got here. Point A, -4, 5, and point B, 3, 5, are 2 vertices of a right triangle. 2 vertices of a right triangle. And this question is saying, what point can be plotted to be the third vertex of a right triangle? Now, here's the thing. There are many, many, many answers to this. There's not just one point. So I'm going to show you a couple of options. So I could pick a point here, right? And that makes a right triangle, even though my line is not straight. Okay. So that could be a right triangle. Let's make that disappear. I could say, pick a point here. And that could make a right triangle. All right, something like that. And let's make that go away. And I could make a point way down here as well and make a right triangle out of that. So we're going to be doing a few problems today where there is more than one way to answer it. So let's go with this last one that I just did. And I plotted a point at 3, -3. So let's write that. And it asks, what is the length of the base? All right, so our horizontal length is this piece right here of the right triangle. So we want to find that length. And so it's in different quadrants, so I'm going to add. And these are my points, right? And I see they both have 5s in it. So I circle the different one. Oops. And so my length of my base is going to be -4 plus 3. And that, of course, is going to be 7. All right. So that's all there is to it. So you're going to be plotting some points and forming some shapes, just like we did in this problem. All right, if you could please go ahead to the next page, please. So I want you to go ahead and answer these questions. I'm going to give you a start, though. So this first question asks about listing the coordinates of the vertices of figure A in the space below, and then wants to know what the dimensions are. So the vertices are going to be the 4 corners, so we need to figure out those coordinates. I'm going to give you the one of them to give you an idea of what you should be writing here. So I see that there's one vertex at 6, 2. And that, of course, is right there. So I want you to find the other 3 and then answer the questions for the length and the width of this rectangle. And let's call the length this piece here, and we'll call this the width. All right, just to make sure we're calculating the same numbers. So go ahead and pause the video and figure out those questions, and then also answer question 2 as well. And then come back and check your answers. All right, check out these answers. There's a couple of things I want to bring your attention to. First of all, both the length and the width are 7, so we're dealing with a square here. So let's actually write that down, just so we have that in our heads. And it asks for perimeter. And if you have forgotten that, perimeter is the entire length around really anything but a polygon. So that's why I added the 7 for the length, the 7 for the width, the 7 for another length, and the 7 for another width in order to get the 28. For number 2, for part A, of course, I found -2 or negative 10, 9. That's just one possible answer. There are many, many possible answers that are correct. But the length of BC, there is only one correct answer for that. The points are in the same quadrant, so I subtracted, and that's how I got 6. Alright, so if you got something different, please see if you can figure out where you might have gone wrong, and after that, go ahead and turn to the next page. Alright, this is another problem that has many answers, so you're going to do your version, and then I'm going to show you my version, and although the numbers will probably be different, the process is still going to be the same. So go ahead and pause the video, come up with your answers, and then compare with mine and make sure that the process is the same, even though the numbers might be a little bit different. Alright, as I did this problem, I realized there actually is only one answer to this one. This was set up a little differently than I realized. So you should get exactly what I get in this, and so they gave you the two corners, right? So only this point and this point is going to be able to make a rectangle. And those points, of course, are negative 7, 5, and negative 9, negative 3. I'm sorry, positive 9, negative 3. So I found the top length first. That's going to be negative 7 plus 9 is 16 when I take the absolute value. The width here, I guess, is 5 and absolute value of negative 3, which is 8. Then I have to add all 4 sides to get the perimeter. So 16 plus 8 plus 16 plus 8, and that gives me a final answer of 48. Alright, go ahead and turn to the next page, please. So here are some more practice problems. Go ahead and pause the video, answer these questions, and then check back to see how you did. Alright, go ahead and check out these answers, noting that number 9, there are many, many possibilities, and you can check with me to see if your answer is right if you're not sure. This one, we had 2 points. Here was 6 away from F on this side was 7, negative 5, and then 6 away from F on this side was negative 5, negative 5. So that's going to be a problem we're going to spend some more time on tomorrow as well. Alright, if you could please turn to the next page once you've checked your answers and figured out if you got any of them wrong. Alright, this is a problem that has many, many answers, so go ahead and pause the video and do your version, and then come back and check, see if my answer is similar to yours and if the process is the same, or just check if I did mine correctly. So go ahead and pause and give this a shot. Alright, you can see the point that I picked, and I picked 7, 7 as mine, and then here's the base of my triangle, the horizontal length, and that's going to be 7 minus 2, and I get 5. Again, your answer is different, but hopefully you can see how I did mine and know if you made if you did yours correctly or not. Alright, so go ahead and turn to the next page. Please complete the video assessment. If you are watching this video in class, you have this sheet given to you. This one's a little bit trickier than some other video assessments, so take your time with this, and when you're finished, you can turn this in and begin your homework. Let me know if you have any questions.